Here's our opening problem for the day. This is just a basic absolute value with an inequality. I wanted you to graph this. Something to make sure that you're focusing on when you graph these kinds of things. Number one, we want to make sure that we know that the vertex is positive 2, comma positive 1. The second thing we're going to look at is going to be the slope. Well, it's not technically a slope, but it's giving me an idea of what to do with my values when I have my vertex. When I go up and left and right, how far do I go up and down, or up or left and right? So these are the two numbers that we're going to take into account. Remember, it's rise, so up and down, over, run, left and right. So this one, since it's 1/3, the smaller the fraction gets, the wider my equation gets. So when I graph this, it should look wider than normal because it's going to have 1/3 rather than just 1. If it had something like 2 or 3 or 10, then it would have been much skinnier to deal with. So let's go ahead and look at that. And so if we graph it, first of all, we know that our vertex is going to be 2, 1. So we plot that point right there. Being very careful to watch for signs. Remember, it's going to be 2, 1, right down here. It's going to be over 2 and up 1. And so to graph the next part, we go ahead and use our slope, our say slope. We're going to take our point. We're going to go here, and we're going to go up 1 and over 1, 2, 3 times. We're going to go up 1 and then over 1, 2, 3 times to the left. Because it was positive, we know that it's going to be opening upwards. Now we go back and we can look at our equation, and we can see that it was less than or equal to, so we have a solid line. We can go ahead and shade that in, and that's the solution. Remember, the three things I look for when I grade your absolute values or inequalities when you're graphing them. Number one, especially if it's absolute value, I'm going to look to see if you plotted the vertex. Number two, I'm going to look to see if you got the actual line or the equation right, meaning did you use the right angle, the slope, did you put it as a solid line or dotted line, and then did you shade correctly. Hopefully this was just like what we did last week and you remembered fairly easily. So let's go on and look at the lesson. Okay, we are going to continue. We're going to talk a little bit more about the same kinds of things, but we're going to try to complicate things a little bit so I can give you a little bit more challenging problems. It's section 5 out of the first chapter, so 1.5. We're going to graph the following systems, and I want you to shade the solution just like normal. Some of these are just lines, vertical lines, horizontal lines. Some of these have absolute value in them. I want you to take a few minutes. I want you to take maybe 5 to 10 minutes, and I want you to graph these. I want you to go ahead and pause the video when you get ready, and I want you to graph them. And then once you're done, you can go ahead and play the video, and we can look at the solution set. Alright, so here is the solution for the first equation. So first thing I'm going to do is I'm going to graph the very first line. So it was y is greater than 1, so it's dotted. And if I go ahead and shade that in, and you get this kind of look. The next one, it said, and remember that y equals, that's always horizontal. Okay? The way that I remember it is when it's y or x equals, it's always opposite from the axes that it goes with. So the y-axis is vertical, so I make sure to draw y equals as a horizontal line. Another thing to remember is that every point on the line that I just drew, every single point right here has a y value of 1. That's what they all have in common. Right? They have different x values, but they all have all the same y values. That's why it's y equals 1 as a line. Okay, the next step would be to graph the next equation. So if we graph this one, this was y is less than or equal to 3. So this is the line y equals 3. If we graph the inequality part of it, it's less than. And so I'm going to shade underneath that. Whoa, too far. Way too far. And so you can see that finished product. You can see that I shaded darker inside. It's a little bit easier with pencil and paper than it is on this thing, but you can see where it overlapped right in between the two lines. This was different than the one we did on Friday because I had you graph above the top line and below the bottom line, and so that was where you didn't have any overlapping at all. That meant that was a no solution problem. In this case, we do have a small section in the middle, right through here, where the shading overlapped. And I went ahead and make sure to darken that in so that whenever somebody's trying to grade my paper, they know exactly what was the solution. Alright, let's look at the next one. Here, we're going to be graphing the first line. It looks like this. And this one was y is less than or equal to negative x minus 1. I went ahead and I graphed my y-intercept first. I used my slope, up 1, oops, there we go, over to the left 1, up 1, left 1. This is a solid line. It's got a negative slope, and it's less than, so that's why we shaded underneath all here. The next part would be to graph the other line, and so you can see here, I'm graphing its y is less than or equal to 1/2 x minus 1. And so I plotted my y-intercept at negative 1. It's up 1 over 1, 2. So we have a slope of positive 1/2. Right? Or up 1 and over 1, 2. Draw my line. This time it's going to be y is less than, so I'm going to also be shading underneath this one. So if we shade that, we get this picture. And it's pretty obvious to see where my shading is doubled. It's where I have two different colors, and we'll go ahead and darken that in. And so you can see this would be my solution set for the second problem set. If I go too fast or you need to slow down, please feel free to pause this at any point in time and rewind or let people catch up. Alright, let's look at the third set. This one is y is greater than or equal to the absolute value of x minus 1 and y is less than 2. Follow along as you've got it written on your paper. I'm going to go ahead and graph my absolute value. I know that the vertex is going to be 1, 0 because it was the absolute value of x minus 1 inside, and so it just shifted to the right 1. It has a slope of up 1 over 1 to the right, up 1 to the left 1, so we have our V shape. This isn't equal to, so it's got a solid line. I'm also going to graph, or I'm going to shade above this line because it's greater than. So you can see a shading there. The next one says y is less than 2. So we're going to have a dotted line. It's y is less than or greater than, so it's going to be a horizontal line at y equals 2. So you can see that line there. And immediately you can already tell what the solution is going to be because we know this is going to be shading underwards. So you can see that it's going to be right in this little triangle right here. So let's go ahead and shade it there. Alright. And we just want to emphasize that, so I'm going to go ahead and darken that in pretty good so I can make sure that, hey, this is my answer. There's no confusion there. Okay, so this is the darkest part. That's the solution set. Okay, and so we're going to kind of switch gears. If you need to pause, if you need to rewatch any of those, please rewind. Something else that this is probably being shown from our website, so don't panic if we're going through this and you're missing a few things. This will be available so you can watch it at any time outside of class. We're going to do something else that we haven't done yet. It's graphing 3 or more inequalities all at the same time. Nothing new. I mean, I'm just going to graph another example on the same line. And so here again, I want you to take a few minutes, take 5 to 10 minutes, and I want you to go ahead and graph these lines, shade them, and make sure to find the solution set for this system of inequalities. So here's the solution set for those two problems. The first one we're going to graph. We graph our line, and so we have y is less than or equal to 1/2 x. No, I'm sorry, negative x plus 2. And so you can see that we've graphed our horizontal or our x or y-intercept. We've used our slope of -1. We've got a solid line because it's equal to, less than or equal to. If we were to shade less than, it's going to be underneath the line. Remember, if you are in any doubt on where to shade, remember always pick a test point. 0, 0 would be great, maybe 0, 1, 0, -1, whichever. Make sure to test a point if you're not sure. Plug it in. If it's true, you shade there. If it's false, shade the other side. The next equation is going to be x is greater than or equal to 1. Since it's x equals, it's going to be a vertical line. And so you can see that here, right there at 1. Since it's greater than, we're going to shade where the greater x values are. That would be on this side of the x-axis. It would be less than on this side. So we can shade in here. If we had graphed 2, you'd clearly see that in this section we have two different color shadings. We have the blue and the black crossing over each other. However, we have three different equations here, so we're going to go ahead and graph our third one. This one says y is greater than negative 2. So we graph the horizontal line, y equals negative 2, and now we shade greater than that. Notice it's a dotted line because it's not equal to. And now you can see in this section right here, makes a little bitty triangle where I have red, I have blue, and I have black. All three fit within this little triangle. So let's go ahead and shade that in really good. And then I can see my solution set. Very clear, very nice, very clear to your grader. Alright, let's do the next one. First line we have is going to be x is greater than or equal to negative 2. So I've got it at negative 2 on the x-axis. Since it's equal to, it's going to be solid. It's x, just an x, so that means vertical line. Okay, going to shade greater than. Remember, x greater than is going to be on to the right side. The next part, we're going to graph y is less than or equal to 0. So y equals 0 is going to be right here along the x-axis. So we'll graph that. This particular one says y is less than or equal to 0, so it's going to be shading underneath. Too much. That's what happens when you hit the wrong button. Okay, here we go. And so we have our line. Our next line is y equals x. Okay, this one is just like what it sounds like. I want to graph the line 1, 1, 2, 2, 3, 3, 4, 4, negative 1, negative 1, but it has a slope of 1 and has an x-intercept or y-intercept of 0. So we graph that point there. We have a slope of 1. So we use our points and we go ahead and graph that. We shade a greater than because it says greater than or equal to. Now look for the overlapping sections. Where does it graph? And I can see here. Go ahead back in. I want to add a few points just to double check because the way I shaded earlier, I didn't actually have color in there. So I went back and I double checked each line. So okay, this one's underneath. This one is to the right. This one is above. And I made sure that I could find a place that they all overlapped each other. Like I said, with a pencil, this tends to be a little bit easier. And this is what you have with 3. You've got them all shaded in, and you've got them all colored, and that's your solution set. Okay. Last example. Use the following information to answer the questions. Now, what I want to do, I guess more importantly, is I want you to get the system set up. That's more important than getting it graphed. This one's actually kind of not so nice to graph because it is a real-life problem. It does have decimals, and we do kind of have to estimate when we go to graph something. And so take another 5 to 10 minutes if you have time left in class to answer this question. If not, you can fast forward the video until the end so that you can see your homework assignment. Depends on how long it took you to graph the other two sets of problems. So be aware of that. If this is going on just a little too long, please go ahead and fast forward. If not, let's go ahead and look at this one. So I'm going to give you another 5 or 10 minutes, and I want you to go through this, write out the equations, talk with each other, use your classmates, kind of ask them what they think, see how they interpret the question. The solution set, we're going to go ahead, I'm going to write out the equations. The first thing we always do in a problem like this is define what x and y are. So we're going to say the number x is going to be the number of hours that we babysit, and y is the number of hours that we worked at our grocery store job. And so the first thing they tell us is that we can't work any more than 24 hours. So that means that we have to work at most 24. So when I add my two equations to my time together, it has to be less than or equal to 24. And so we set that up. Oops, there we go, less than or equal to 24. And the next equation is money. This one's actually kind of pretty straightforward in terms of writing out the equations. We've done a number of these. It just hasn't been inequalities. It's going to be basically the way that I calculated my money. 7x, because it's the number of hours for my babysitting job times how much I get paid. Then it's the same thing. It's going to be 650 times y. Now, in the problem it says that you have to have at least $100 in order to make your budget or to pay your bills. So we need more than 100. So if we got 100, it's great, or if we got more than 100. So this part of the equation, this part right here needs to be more than or equal to 100. So write that out like this, and you've got your two systems or your two equations to write it out. If we keep going, I'm going to go ahead and I'm going to simplify those two so that I can go ahead and get ready to graph them, and we'll look at it. I keep writing greater than. There we go. So that's the first one. Basically just subtracted x from both sides. So you've got your equation here. Just subtract x, and you get this one. The next equation is a little trickier. I went ahead and I left mine in fraction form so that I could see the slope, but for the y-intercept, I gave myself a decimal. 14 over 13, I get that. That's fairly decent. I can do that, although 14 is really a big number. 13 is pretty big. But we're going to try something different in terms of graphing, so hold on a minute on that part. I'm going to go ahead and label my values. I'm going to go up by 5s. Now, let's pause for a minute. This equation is, I really don't want to have to graph 14 over 13. 15.4 is okay. I can go ahead. I can go up here to 15.4. That's probably right somewhere in here. I'm not trying to be super specific. And so let's try the zero method, finding x and y intercepts. That might be a little bit easier. I got the x or the y-intercept from these two equations. So I'm going to have a point at 24. I'm going to have a point at 15.4 on the y-axis right up in here. That's easy. I can go ahead and plot those. But what the question is, where along the x-axis is my point going to be? So let's plug 0 in for y right here in both of these equations, and let's see if we can find our x-intercept. So this is what it would look like here. So I plug 0 in that one works out really easy. You're going to add x to both sides, and you're going to get x is 24. And so I'm going to come up here, and I'm going to label my axis here and put a dot at 24. And so we get 25. So there's my two dots for my first equation. I put one at 24, way up here. And I put another one down at 24 down here. And since I only need 2 points, I can go ahead and draw my line in right there. The next one we're going to go in, and we're going to put our dot at 15.4, and I'm just getting close as I can. That's about 15.5, and since we're going up by 5s, that's kind of impossible to actually try, so just get pretty close. Next part, we're going to find our 0 for the other one. Okay, and so here's how the 0 works. I went ahead, I plugged in 0, I just basically added or subtracted the 15.4 to both sides. You can see that here, and then we multiply by the reciprocal. And this is what we end up with. Since they all cancel out, you're left with x equals 14.3. And that's what you can see plotted right there. Remember, this video's up. If that was kind of fast, if you didn't catch all that, this is up. You can watch this a million times if you really need to. Or you can ask me questions when you come into class tomorrow. Alright, and so I graph that line as 2 dots. Just connect the dots. The slopes are almost the same, not quite the same. We have a -1 slope, and then we have one that's just slightly larger than -1. And so you can see the equation. One is greater than, one is less than, so it makes sense to put them in right there. Now the question says, what were 2 sets of hours that we could work for each of the different places? And anywhere in the shaded region, you pick any points that fall in there. So look in there and just look for an intersection grids and just say pull them out. And so I'm going to pick a couple that I found. So 7 and 11 would work, and 9 and 9 will work. And there are plenty others that would also work. And you could just tell me any of those in there, which would allow you to solve this system and keep going with it. Alright, here's your homework. If there is class time left over in the class, Please take time, and I want you to start on this, number 1 through 4, all 5 through 19 odd, and then 25, 26. 1 through 4 is a lot. It's kind of asking some basic questions about graphing and inequalities, and 5 through 19 is going to be basically what we did in class today. We've got your graphing, your systems, and solving and shading. 25, 26 is a word problem. Take those, look at those, and then we'll talk about this tomorrow in class. I'll see you tomorrow.